All right, algebra kiddos, welcome to the end of your Wednesday. Hopefully you've had a good day thus far. At this point, everybody should have turned in their key features of graph day 2. That's the one that we did yesterday. The top is called shapes of graphs. So everybody should have turned that in. Done or not, turn it in. I'll go over it and answer any questions with you when I get back on Thursday. So if you need to pause this video, pause it right now so that everybody can turn that into the hand-in box on my desk. All of you should also have your next worksheet out. Today's worksheet, I called it worksheet 3 up on the board, but it's called sketching graphs and comparing functions. Everybody has that. Again, don't panic. Yes, I know it's a packet, but remember, it's got your notes and lots of graphs in there. All right, so we sketched the graph of a function based on knowing the domain, the x's, the range, the y's, the intercepts, where it crosses your x or y axis. Can you fold that graph on any vertical line to match up? What are the ends doing? Are they going up or are they going down? Extrema, remember, are your maxes or mins. Where is it increasing, decreasing, where it's going up, left to right, or down, left to right? Positive, negative, above the x-axis and below the x-axis. And knowing all those different pieces can help you draw a graph. So some of the things over here, we give a graph and they ask us to label them. Some of them are pretty obvious, like the one at the top right here. This one's pretty obvious that that is a relative maximum. That is the highest point in that area, a relative maximum. On the opposite side down here, we have a relative minimum. And remember, relative minimum. Relative means in that region, it's the lowest point. There's other things that they have kind of highlighted in here. This middle section here would be a decreasing section. As you read your graph left to right, that area is going down. Over here, we could talk about this as a positive section because it's above the x-axis. Down here, we could talk about this as a negative section. There's lots of different labels that we could actually put on here. When I looked at this originally, you could also label this section as increasing. You could label this section as positive. You could label this section as increasing. You could label that as end behavior. So it really depends on what specific area they're talking about. So what's going to happen today is they're going to give us a whole bunch of information. They're going to tell us about where things are positive, negative, increasing, decreasing, relative max, min, your end behavior, and your symmetry. And we have to draw the graph to the best of our ability. Now, is everybody's going to look the same? No. But are they going to be very similar? Yes. There's certain pieces that you should know. As you're doing this, I would make sure to draw lightly to start with in case you have to erase anything. And then you can always darken it once you actually figure out what you're going for here. All right, so it says a person's happiness can be affected by the temperature. Sketch a non-linear graph, meaning not a line, that shows the happiness of a person, which is on our y-axis, as a function of the temperature x. Interpret the key features. So if we look down at our graph real quick, we have temperature on the x-axis and happiness on the y. So it tells us it is positive between 25 degrees and 89 degrees. Remember, they're giving us x values. Positive means it's above the x-axis. Is above the x-axis. So I know that these two have to be x-intercepts. So I know on my graph at 25 and at 89, I need to have an intercept. So be careful of your scale here. Watch your scale on your x and your y-axis. At 25, so I'm going to put a dot here, and at 89, a dot here. And I know those are x-intercepts because it says it's positive between those two. So in this region, don't you highlight it, but in this region, positive means it's above the x-axis. So my graph is going to occur above my x-axis. It goes on to say it's negative for temperatures less than 25 degrees and greater than 89, which makes sense. Negative means below the x-axis. So over here, I'm going to be below the x-axis, and to the right, I'm also going to be below. I'm going to be down here. It is increasing for temperatures less than 57. Now, increasing means as I go from the left side to the right side, it's going up. And it says it's increasing for temps less than 57. So 57 degrees must be important here. It's decreasing or going down for temperatures greater than 57 degrees. Ooh, here's a key word, relative. Get a different color highlighter here. Relative maximum, here's a high point at 57 degrees, and they tell us the happiness is 85. This is a point actually on our graph. So 57 is our x, and 85 is our y. So we actually want to plot that on our graph. 57, 85, somewhere close to that. Now that makes sense with our increasing and decreasing, right? When it's less than 57 or to the left of that point, it's going to be increasing. And when it's greater than 57, it's going to be decreasing. End behavior, that means on the ends of my graph, as temperature increases or decreases, our happiness decreases. So I know the end of my graph, they have to be going down. I know the ends are going down. Symmetry, this is where we fold our graph. A person's happiness for temperatures less than 57 is the same as temperatures greater than 57. So that means, yes, there's symmetry. The left side needs to look exactly the same as the right side. Okay, so I almost could draw my vertical line here, and I know the left side of my graph has to match the right side. I have to stay above the x-axis in the yellow and below the x-axis in the blue. To the left of 57, I have to be increasing, and to the right of 57, I have to be decreasing. So not even worrying about the ends right now, I know that this has to come up and go back down, and you're going to try to make it as close as you can. Mine's not great, but I know that it has to continue to go down, and end behavior says they're going to continue to point down. So for you guys, you should have something that looks like so. Now, is everybody's going to be identical? No, but your left side should match the right side because it says, yes, it has symmetry. And this is why I say, like, this area over here is really good for like little notes. Like, I know they give you this information, but to draw yourself little sketches. But then also we might have to put some extra points on that graph like I did with that highlighter and then erase it. Now, obviously you guys don't want to use a highlighter because you can't erase that, but maybe a small sketch before you actually draw yours. All right, I'm going to give you time right now. I want you to flip the page over, and I want you to see if you can give me a graph for the roller coaster on your own. On the next page, read through all of these. Everybody on your own, read through these and see what you can do. All right, if you guys need more time, pause this video. But if you guys are in a spot where either you need help or you want to double check what you have, follow along with me. All right, positive between x equals negative 0.5 and x equals 12. So again, that tells me those have to be my x-intercepts. So negative 0.5 and at 12. Watch your scale. So it's positive in between there, negative to the left of negative 0.5 and to the right of 12. So again, kind of like our last one, it's positive in the middle, negative on the ends. Increasing for when x is greater than 1.4 and between x equals 5.3 and 1.9. So I'm just going to make a little note to myself over here. Increasing greater than 1.4 and 5.3 to 9.9. Decreasing 1.4 to 5.3 and greater than 9.9. The graph intercepts, the x-axis at negative 0.50 and at 12, which we have, but then it says it intersects the y-axis at 0 to 20. So that's another important point to put in there. A relative minimum, 5.3133. A maximum at 1.4448 and 9.9643. So like right now we have all these random points, but they're going to come into play. Okay. Notice 1.4 is this point we just did. It's increasing when x is greater than 1.4 and between 5.3. That does not make sense. I think that's supposed to say less than 1.4. I think I have a typo in here. I think this should say it's increasing when x is less than 1.4. Otherwise, it's not going to be. If it's increasing up to that point, but then it would have to decrease, right? So it's going to increase up to 1.4, then it's going to decrease, then it's going to go back to increasing, then it's going to decrease. So our graph's going to go up, down, which makes sense off of our points. End behavior, as x increases and decreases, the value of y decreases. So same thing, going to be going down at the ends. Now notice there's no symmetry on this, which makes sense, okay? So I know, I'm going to make my marker a little bit thicker here. I know that I am going to have to make my graph come up. But I got to be careful because this is got to be our two intercepts here, right? It's going to come up and it's going to increase to my max. It's going to come down to a min. It's going to go up to a max, and then it's going to come back down, making sure to go through there. Staying above the x-axis between these two, below the x-axis on the outsides, your max, your min, your max, and my end behaviors are both going down. Now, obviously, everybody's graph can look a little bit different, but we have to make sure we hit those key points of your maxes or your mins. I apologize for that typo in there. All right, let's go to the next one. Hawkeye is a computer system used in tennis to track the path of the ball. It is used as an officiating aid to locate the landing spot of a tennis ball when players challenge a call. Use the description and the graph of the player's forehand and backhand shots to compare the paths of the two shots if y is the vertical height and x is the distance. So they give us our descriptions. Forehand. During the forehand, the ball leaves the player's racket at a height of 2.8 feet and travels 29 feet, where it reaches a height of about 10 feet. Then the height of the ball decreases as it hits the ground 58 feet from where it was hit. The backhand gives us a graph. Now, I'm not going to lie to you. Those sentences instantly make me panic. So I want to make a quick sketch. Okay? Important pieces. It leaves the racket at 2.8. So I would say it's going to leave here at 2.8 on your y-axis, the height. It travels 29 feet where it's 10 feet in the air. So at 29 feet, yep, and then it's 10 feet in the air. That's your maximum. Then it starts to decrease till it hits the ground 58 feet from where it was hit. So out here at 58, it's going to hit the ground. So it's going to mimic your backhand with a little bit different arc to it. So it's going to go up and come back down. So they put our information into a table here. And it says our x-intercept on the forehand is at 58, on the backhand is at 70. The y-intercept on the forehand is at 2.8 and the backhand at 2.5. Our extrema, which is our maxes or our mins, a max height of 10 feet when x is 29, a max height of 7 feet when x is 35. Increasing and decreasing, it gives you your description. So now we need to read through and answer these questions. I'm going to give you a minute here. Read through and see what you can fill in. You're analyzing the data, comparing the forehand to the backhand. All right, our x-intercept. The ball travels 12 feet further during the backhand shot. And I know that because my x-intercept is further out than my forehand. The y-intercept. The y-intercepts of the two functions mean that the tennis ball is about 0.3 feet higher at the beginning of the forehand shot. Extrema. The maximum height of the tennis ball is 3 feet higher during the forehand shot. Increasing and decreasing. This was probably the hardest one. The height of the tennis ball increases over a shorter or smaller interval during the forehand. And I know that because it only takes 29 feet, height of 10 feet at 29 or a height of feet at 7 at 35. So 29 is less than 35. It increases over a smaller interval during the forehand shot, but it reaches a higher maximum height. This means that the tennis ball increases at a higher rate or faster rate during the forehand. It's going to climb quicker, goes higher in a shorter amount of time. All of those key features. And it goes back to truthfully knowing the definitions. Where is positive? Where is negative? What does that mean? What does increasing mean? Increasing doesn't mean it has to be really steep. Increasing could be just a subtle incline. All right? Pencils down and hear me out here. I did this actually on accident, but I think it's going to be okay. If you want to separate your packet into two separate chunks at this point, I put all of the homework information. Actually, no, I am missing information for you on this. So just a second and you will get that information as a second sheet of paper. Sorry, I apologize. And then your graphs are on the pages to follow. Okay, so it'll actually work out for you. I give you the quick synopsis of this, and then there'll be another sheet of paper that you need to get that's got the key features on there. Where is it increasing? Where is it decreasing? So on and so forth. You guys know my rules. You're doing this on your own. I don't want you working together. Small questions of clarification are fine, but really you should be working quietly on your own. Your sub will let you know at 3:08 that it is time to pack up. Do not turn these in. You will go over them with me on Thursday. Volleyball girls that are going to be gone on Thursday, make sure you complete that practice. I will have the answer key posted on my lesson plan so that you can check it as you go. Be prepared. You will be taking that quiz on Friday. If you need to see me in enrichment on Thursday or before school on Friday or enrichment on Friday, that's totally acceptable for anyone and everyone. All right, make sure you have that second page, and then you can go ahead and get started on drawing your 6 graphs.